So our next speaker today then is Peter Thermos from Palindrome Technologies, speaking to Hydra, 5G and Wi-Fi, network coexistence and convergence solution. Peter?
Thank you, Chris. I'm going to disable my camera just to avoid any network degradation because of the video, and then I'll turn it back on at the end, okay? Good afternoon. I hope everyone had an enjoyable 4th of July celebration, and to all servicemen and women, we would like to express our gratitude. Thank you for your sacrifice and bravery. I'm Peter Thermos with Palindrome Technologies, and today I will be presenting our solution we developed to address challenges in heterogeneous networks. The research was funded by DHS and started in 2021 with focus on investigating challenges with coexistent wireless technologies such as 5G and Wi-Fi 6, as well as developing a prototype to manage unified access in heterogeneous networks to demonstrate communications resilience and viability of our approach. Over the past few years, there has been some research in the area of heterogeneous networking to help understand how to improve quality of user experience using various network optimization techniques and approaches. However, we still have limited understanding of network coexistent models that address network discovery, mobility management, interference coordination, and security across heterogeneous wireless technologies. In addition, the interfaces between private and public networks are sometimes inefficient and lack interoperability. For example, a user has a challenge of selecting the best available wireless technology by relying on their IT department or service provider, or even forcing manual overriding cases. I'm sure some of you have experienced session disruption while watching Netflix, and while you start moving away from your home Wi-Fi coverage to your cellular coverage, you may need to restart your session. So although this experience may not be as detrimental to the average individual, critical mission applications that suffer such network interruptions may impact the outcome of a mission and ultimately may have dire consequences. So during our initial effort in phase one, we investigated existing wireless standards and technologies to identify the challenges and come up with applicable solutions. So the three challenges that we surmised across the research that has been done so far are on performance and reliability, where the coexistence of network technologies such as public or private 5G and Wi-Fi offer different strengths and limitations for quality and reliability, which render the overall quality of experience questionable for users in the context of heterogeneous networks. The other area is security, where the security controls at the signaling and transport layers may vary between technologies and provider implementations, which may lower the confidence for adaptability and usability. And the last one, which is the interface and access policy complexity, where interfaces between private and public networks are complex, with different access profiles and policy configurations between the UE and the network. So in order to address these challenges, we need to develop a mechanism for unified access, intelligent policy management, and device orchestration. So Hydra is a prototype we developed to investigate the interoperability and security implications of 5G and Wi-Fi 6, also CBRS, to support federal users. Furthermore, our architecture is designed to offer a modular, unified mobility management solution that can dynamically select one or more network access links on the device based on policy definition that meets the federal users' requirements for QoS and security. Here are example organizations that may benefit from this work, which includes federal, state, and local government first responders. And our platform aims in addressing network resiliency and support the needs for situational awareness when using real-time multimedia applications and collaboration services. A differentiation has started to emerge between the notion of headnets and heterogeneous networks, in which headnets are focused mostly on implementations that use the same shared spectrum and same wireless technology, for example, LTE, whereas heterogeneous networks include different technologies, 5G, Wi-Fi, and different access methods as well. So we may use the abbreviated form of headnets in our presentation for simplicity when we're referring to heterogeneous networks as well, but there is a distinction as the technology has evolved. Some of the limitations of existing approaches include the fact that Current HEDNET architectures focus on managing the same shared spectrum, whereas heterogeneous networks aim in providing access that is independent of the wireless access spectrum being used, 5G or Wi-Fi. Also, the current solutions tend to be vendor proprietary and typically provided and managed by a single network operator. Also, the performance can be unpredictable at times and often leads to unfair spectrum sharing or shutting one of the technologies for the other one to operate. Also, the inability to coordinate between various security controls offered by existing implementations is another challenge. And lastly, we have the lack of intelligent device orchestration across different RF technologies and vendors. Whereas in the Hydra design, we aim in providing a device-agnostic, unified network access and intelligent policy-based device orchestration to support QoS and security requirements. It is understood that HEDNETs introduce challenges, and therefore we need a capability to ensure continuous resilient communications for mission-critical applications. So mobile users require a next-generation network as a service platform that can be deployed on mobile edge clouds and offer granular policy-based networking and security controls that can operate across public and private cellular and Wi-Fi networks. We need to focus on investigating communications resiliency at the application layer rather than trying to merely optimize signal strength by calibrating network elements that users may not have access to. So the notion of homologous communications focuses on providing an abstraction layer between the application and the underlying network infrastructure and leveraging network optimization techniques to ensure resiliency. The core objective of Hydra is to facilitate communications resiliency by providing a device-agnostic unified network access with intelligent policy-based device orchestration. And the customer requirements that are listed here were developed through our research. I'm going to focus on the first four due to time constraints. Number one, we have seamless user experience. Users should be able to maintain connectivity as they roam and hand it off to other networking technologies, where they attach to private or public networks managed by different service providers and access different services. Disruption tolerance, applications and services should be able to continue to operate when connectivity is lost for short periods of time, and also provide the ability to recover sessions during longer disruptions. Secure communications, there should be a security model to address resource and service access, protection of the different protocol layers, federal domain network devices, internet networking gateways, and data in transit or store protection. And lastly, user mobility and device independence, where devices need to continue to operate consistently regardless of the underlying wireless technology that is being offered. As I mentioned, our prototype attempts to explore how to manage network access and device identity regardless of the radio technology to which the UE is connecting. It can implement federal policies and requirements to support specific user cases and corresponding QoS and security characteristics. Our design proposes an enhanced protocol suite that is capable of controlling the underlying network and middleware orchestration through the control plane in order to support federal users end-to-end services in the data plane for converged 5G and Wi-Fi 6 networks. The core components of the Hydra architecture include the Hydra Manager, Policy Engine, Access Manager, and the Hydra Client. The Hydra Manager functions are comprised of the mobility management function, which helps manage different layers of the protocol stack and interacts with the control management middleware to support local and global mobility. And it also works to optimize handovers, reduce mobility-related control signaling messages. The policy management function manages the decision-making process to select the right network access and enforcement of corresponding policy controls. And it relies on real-time and unreal-time data feeds to understand data elements and enforce policy criteria. Lastly, the domain access management function is responsible for managing the provisioning, registration, and access control, and access on the front end, UE interaction, user equipment interactions, and the back-end federal network domain applications as necessary. It can maintain detailed security monitoring for the solution and provides trust establishment for resources and network services. And it also provides functionality for identity management in order to manage the user device identities and credentials. The Hydra client provides an enhanced wireless protocol stack to assist with selecting the optimal wireless technology based on a specific policy and corresponding requirements in support of a use case scenario. The controller in the Hydra client provides multi-homing access, mobility management, and disruption tolerance. It offers traffic control and prioritization per application based on policy requirements. For example, the network health or the day that certain type of traffic or application should be forwarding traffic. The controller also can route traffic via the Hydra core network or only route traffic of selected apps. And if required, the client can also enforce state controls such as terminating a connection, transparently proxying connections, and maintaining connection state tables to facilitate connection persistence when changing link channels. In this example, the client sends a registration request which is received by the mobility manager, and the mobility manager facilitates the UE registration with the domain access manager. Once the registration is successful, the mobility manager contacts the policy management function to retrieve the appropriate policy for the corresponding UE. And the policy may contain several policy statements, nested statements that correspond to several use cases. For example, you may have a policy that states if you are between 9 a.m. and 11 a.m. in location XYZ, and the bandwidth is below 10 gigabits, switch to Wi-Fi 6 or some kind of other interface that is available. There are basic principles that guided the development of the Hydra policy management designed to meet current requirements and the evolving standards, run products, and deployments. And these principles include architecture, modularity, policy-driven decision-making, network access, management orchestration, underlying network technology agnostic, and seamless coexistent internet working. Existing solutions are limited to vendor proprietary approaches, focusing on optimizing the use of radio frequency spectrum. For example, if technologies from different vendors are used in a coexistent deployment of Wi-Fi 6 and 5G, then spectrum optimization is not possible. Hydra design alleviates this need by providing a device and vendor agnostic unified network access and intelligent policy-based device orchestration to support QoS and security requirements, as I mentioned. We have completed phase 2 in April and demonstrated the viability of our concept in our prototype to our funding agency, DHS. And our intent is to explore partnerships and funding vehicles with interested agencies to continue towards the development of a commercial solution that will support federal mission requirements. We included contact information at the end of this presentation in case you're interested in having more detailed discussions. And as far as our commercialization strategy, we're still in early stages in our efforts, and we're interested in identifying resources and partners, as I mentioned, to assist with our research and development efforts. The important areas where we need assistance to mature the Hydra prototype into a robust and scalable solution for federal use includes partnering with interested agencies who are willing to share use cases, requirements to incorporate in the design, and also identify testbeds to pilot the solution. Lastly, the ability to explore funding vehicles to support the development and commercialization. A little bit about Palindrome Technologies. We are a firm in Princeton, out of Princeton, New Jersey. We've been focusing on telecommunications security and cybersecurity for the past 25 years or so. Ex-Bellcore Bell Labs principals are the heads of the firm, and we specialized in product testing, network testing, and security assurance. And these are the contact information of our team that has supported this effort. If you have any questions, don't hesitate to reach out to us. Thank you, and I hope you enjoy the remaining presentation.